So yesterday we've had a talk by Fabian Buch. We also had this afternoon session, and there were many allusions already. This is an attempt to give a systematic overview of what's there, and it is already 16 years ago that I started to make this systematic. It's already a long time ago. There's a link on this Google Doc to these slides. And here I make this canonical self-reference, or the PDF, and here the sources. It's always, for me, Isabelle is a system to make talks about Isabelle. And here the sources, and you can amuse yourself with this material. This is my PDF version of that. Yesterday, in Fabian's talk, there was also this tetrapod, and then it was about narration and so on. So Isabelle is a document preparation system for formal content. The only formal content here are hyperlinks in this document. So yeah, here I point to the normal documentation of. Should have practiced that with this funny. Okay, this is the pointer. I do this with the mouse pointer. So this is the normal documentation, and there's this section here, project setup for the common Scala IDEs. This is talk is mostly about Isabelle Scala, and we outsource the responsibility for the IDE in Scala. I regret that, so this will change within the next 5 years or so. 5 years ago, we were all happy with the IntelliJ idea. This explains how to turn Isabelle Scala into a normal Scala project that any Scala IDE can use, and then you can use IntelliJ idea on that, and it basically works, but it's not good. It degraded a lot. So we need to incorporate this at some point, that we are really self-contained. I will never outsource the responsibility for really, really important things. So this is what I learned from there. So already an important conclusion. So don't rely on fine companies and great people there. They say, oh, we have the best Scala IDE, and then 5 years later, it doesn't quite work. Okay, so what is Isabelle? So this is a very difficult question to answer. So in this talk, so let's start, let's assume that, or pretend that this is an interactive de-improver. But it's also a prover IDE, PIDE. And I've pointed already, there's this Euphrat place where you can actually eat some PIDE there at the Hauptbahnhof. Prover IDE. So prover IDE means you have an editor, and it gives you semantic annotations for the languages that you edit, and it's for many, many languages. Isabelle has many important languages that you use all the time, like for specifications here in proofs. So to produce the theory content, you use HOL, and many people, when they say Isabelle, they mean HOL, together with the ISA proof language, the language for proofs. But also for functional programs inside the implementation of the logic, which is Isabelle ML. And this IDE integrates everything, so you just hop back and forth between editors and IDEs. You do this in one environment. And here's my IDE for this talk. And let's go to some formal content that you normally expect in Isabelle HOL. So let's go to this sum of square thing that we've seen yesterday, also the people who were in this afternoon session. So this is a normal Isabelle Hall theory, and I could write theorem statements here and prove them. But here I'm loading ML modules to define a proof tool. And this is done in Isabelle ML, and then I just have the normal IDE access here for everything. So you just hop between the languages and you don't think about that. So other systems, they try to have everything in one language, and then you're not surprised that it works, that your editor works for the one language. But Isabelle integrates many languages in this interaction model, and this tooling, in this IDE model. This is an important observation. Yeah, it's a formal document preparation system. You've seen this slide's source already, and this is the PDF narration of that. And it's a system integration platform based on Scala and the Java virtual machine. And many decades ago, we still had these scripts to do the system. So this is the system integration. And in 2008, in summer 2008, I said, okay, let's make this systematic. Let's do this on the Java virtual machine. The motivation for me was the IDEs were there. Like Eclipse, everybody was talking about Eclipse, now it has changed. And later there was IntelliJ, and I was using the J text editor, which was also on the Java virtual machine. So I had some motivation to be on this platform, but I didn't want to do Java programming with Java 6. With Java 8, Java has become a functional programming language, so maybe I would have done Java if it had been there already. But I started using Scala, and I'm using Scala like ML. The programming style is pretty much like Isabelle ML. So in this talk, well, Isabelle is an environment to develop itself, to document itself, to maintain itself, to build itself, to run itself. Self-application, yeah?
Just a quick reminder, I think I remember at some point you telling me that Isabelle also ships its own version of LaTeX, right?
We don't do this, no, this is outsourced. LaTeX is outsourced, and it breaks all the time. Yeah. So when automated tests break, you have a bad LaTeX installation. Yeah. And at some point, I would really integrate this better to say there is some self-contained sub-language that we pass and so on. And I'm very interested to read this blueprint session, so I want to learn what to do after the actual LaTeX. So LaTeX is some legacy thing that we're still using, and it breaks all the time. When there's a small change there, everything breaks. Yeah, okay. Self-application, so I could build a rather small system with these principles, but by having actual applications, I proved that this is a substantial system that is applied to itself. So our AFP is our main application. This is where things happen. 20 years ago it was founded. In March 2004 it was founded. There were maybe 10 entries taken from the normal Isabelle distribution and moved over to AFP. And a couple of years later I said, okay, we need to build technology to support that. In 2006 it was already heavy and requiring 2 or 4 hours to build, and this was ridiculously small. And then it keeps us busy, or it keeps us exercised. So, so it somehow imposes a lot of demands on the platform. We will see more about AFP later. This is again about Isabelle, important principles about Isabelle. So these are just sort of cultural background. I always say authors of formal mathematics or formal proof documents. I never say developers or coders. If you go to other people who do mathematics, so would you call somebody who writes a mathematics LaTeX document a programmer? LaTeX is a programming language, and this is not a programmer. So that you're an author and you're using some language that has a computational aspect or whatever. So I think of our users as authors of mathematical documents. Everything should work on the usual platforms. This is a lot of work. In 2008, I started this ambition to have Linux, Windows, and macOS working all the time. Now we have all these ARM platforms. So this usually works. And it depends also a little bit on the users to complain when something does not work. For example, Windows. I try to test this myself, but I'm a Linux user, and here I'm just sort of a part-time user to test this, so the users need to complain if something doesn't work. The main dependencies are bundled. They are excluding IntelliJ and LaTeX. And for LaTeX, I would say, let's somehow get rid of so it should be supported, but not required, that we can have an HTML rendering of our formal content. And our source language is already far removed from actual LaTeX. There's very little actual LaTeX in there. You can do all the fine LaTeX tricks to produce journal articles, so users are doing that. But normally I would say for AFP entries, you should restrict yourself that we don't need actual LaTeX. At some point I would like to see this happening, and we are not there yet. Okay, but everything is bundled, so Java, Scala, and external provers, and Java libraries that we need, and so everything is bundled. And what we deliver is 2 gigabytes directory content. And normally people don't notice this and they don't complain. So it's very rare that someone comes to me, you're using too much file system space here locally. And the normal LaTeX on a Mac is 5 gigabytes. And I think you just accept that. 2 gigabytes, yeah?
This is excluding AFP, I suppose.
Pardon?
This is not including AFP.
This is normal Isabelle. AFP is a separate thing.
How big is AFP?
This will come in a couple of slides. This is all about Isabelle as the basis, for the technological basis. You just download everything, you get these 2 gigs, and then you can use AFP. This is some handiwork where you need to connect this. At some point there will be just the AFP button, I want to use AFP, and then it's integrated into...
So which images does this include?
Pardon?
Which belts does this include? Like you provide these ML...
This includes everything, and I have a small overview here. So the ML system, the Scala environment with the JVM, the editor, and some external libraries to connect to.
I was asking about these heaps that you provide.
Yeah, so we provide an HOL heap. So there's an Isabelle Scala tool to make the release, and if you do this yourself, let's say you have add-on tools and you make your own branding of Isabelle with add-ons, you have a command and option to say, what are the images I would like to include in the release? I normally ship whole, which is 280 megabytes, the image, and I could ship whole analysis, another 200 megabytes. And maybe I will do this eventually. Nobody will notice that this is getting here to 2.5 gigs or something like that.
And like, did you consider doing some bigger heap or whatever you call it, also for AFP? Like
for AFP? Yeah, so I would say, so the shipping the whole image is motivated by, let's say there's an introductory course and it should work on the spot and people are sitting there with battery power, it should work on the spot. If you're properly connected and do bigger things, building the image, well, you just have a command and option to say what is your image, and it will build on the spot and it will take 5 minutes or so. But you better connect to the socket there. I've seen this one. I keep watching the ITP conferences in the back of a lecture. It's very interesting to see the people there with their laptops, what they are doing. 2013, Larry Paulson was sitting there doing proofs with Sledgehammer, and suddenly he was connecting his very high-end Mac to a socket. And then I saw from a distance, okay, I need to do something about that. This is getting too hot. But yeah, so maybe I include whole analysis next time or something like that. So it's, the tool is there to build a release. Okay, let's briefly go back here. This is the IDE. We've seen this already in action. This state of affairs here is maybe, so it started to become usable in 2012. And in 2016 or so, it's reached a certain state where I didn't get very far beyond that. I will pick it up again to have more things, so to have more fine points being sorted out. And this was really, really smoothly. The main IDE based on the text editor. Often people call this JEdit, but it isn't. These people have never seen the original JEdit. It looks totally different. Florian knows it. The original JEdit looks quite different. So the Isabelle JEdit Proof IDE is really something different and something new.
Can you explain the stateless document model? Because proof development is very stateful.
Yeah.
So why is the...
Stateless means so that you don't keep the state in your mind where I am in stepping through the thing. So you don't step... In proof general, we had this model to say, assert to that point, and it's a certain state. The editor somehow reflects the state. Here you just type into the buffer. This acts like spell checking in Microsoft Word, or that's LibreOffice spell checking. So I just type, and the system will react on what I type on the spot without myself doing anything. So now I need to import main hold, and I have this notation. So I just type, and it never stops me from typing, and will try to check what's there. If I'm interested in intermediate states, I have possibilities here to somehow to inspect the state. So let's say at this point, or here, then I see this state. But somehow the system reacts to my edits
I think the comparison here is to like those Python, what do you call it, the
Jupyter?
Jupyter workspaces.
This is a stateful model.
But that's a stateful model where like the same text,
Yeah.
you know, you can run it and then you go back and now you have to remember what was run in the future and so on.
And also in Mathematica, in original Mathematica notebooks, there are these funny tricks that you define A and then you delete information that and this can never happen here. So we used to have, and later maybe here in the discussions, I want to see what are the lean guys doing now concerning this editor model. I want to understand this, how it's done and how this compares.
So this works great if everything is essentially instantaneous.
Yes,
Your interaction starts being at the level of a minute per keystroke.
Yes. This was a very interesting experience. So we had Proof General until 2014, and then some guy who visited me in Augsburg, he said, okay, so now you can delete Proof General, so nobody will care about this anymore. So we had to convert the 2 or 3 users who were still on Proof General, and they had a style where an individual step would take long. They had to change their style. And this was very beneficial to the overall quality. It needs to react fast, and you tune your proofs according to different parameters to make it feel reactive here. And suddenly, all the proofs became much faster.
Are you claiming that all proofs can be fast?
But just empirically, if you look at the AFP entries, let's say 15 years ago or so, there are some entries where every step can take really, really long, and this doesn't happen anymore. This was really beneficial to have this pressure on the users. Yes?
Yeah, so when it's busy inside a proof, it already in another core skips that proof and continues with the rest of the document? Or?
So I could do this, and at some point I will implement this, but here the scheduling of checking the document is very simplistic, and it's from 10 years ago,
Okay, so
20 years
that's
ago.
not
At some point I will really take the tree structure, the hierarchical structure of the text into account. As you edit, it will be skipped over or parallelized and so on. It is relatively naive here, and it works fine so far. It has past 10 years or so, and I might revisit this rather soon. But you do get, let's say we have something that takes long, like something like that. So then you will see that here. You see this purple. But if I say, okay, so I want to get rid of that, so you somehow destroy that, so it will be reactive in being interruptible. And I spent many, many years to convince the external prover authors that they should deliver tools that are interruptible. And then on conferences, I say, oh, you're the guy who has a C++ program. When I interrupt it, it crashes in a crazy state. But we are in a pretty good situation there. Also, Jasmin Blanchette knows these external prover guys pretty well, and he always tells them about how good the integration is here. Okay, we still have a little bit of time. So they have the main technology, so ML by David Matthews 40 years ago. So he started this. Larry Potts and David Matthews were sharing an office in Cambridge, and one guy doing the ML implementation, the other guy a prover. And this is highly tuned for Isabelle applications. Here we have the normal OpenJDK. Most people are now using the Azul version, it's a free version, very high quality. So Java now delivers what it claimed 30 years ago. JLIT is a project that's on flat line, so it neither goes up nor down. So there's some retired Java programmers who still maintain that. Recently they made a patch to have this on Java 21. Some years ago I had to submit many, many patches to make this work on the 4K displays, the high resolution displays. I had to do this myself, and also for French macOS keyboards and these kind of things. But this is sort of flat line, so this continues. SQL support, so now when we produce things, so ML has its own database that's opaque, we cannot look into that. And for Isabelle Scala, we write out things. And the user can also say, I want to write out blobs. So it's like a zip file in the database. In Isabelle ML, you say, please store this in my build database. You don't write out to the file system. This would be bad in the IDE as you edit, writing out files as you edit, so that you have many versions, or maybe you change the name, then you have all these ABC files lying around if you edit the name and so on. So this must be stateless. And this database model is stateless. So at a certain point, we commit to the database, and that's it. And when you have intermediate states, we take back the database state. It's not ending up yet in the database. So the local version is SQLite, like Firefox and Thunderbird. Everybody's using SQLite. This is nice. And for a server version, we use PostgreSQL, and we have a unified programming model here, Isabelle Scala. For the cluster build system that Fabian, he did most of the work, then everything ends up in the Postgres server. So normal Linux Postgres server. I also made this huge database of all the log files since 2002, where we then can query what was the timing and so on at a certain stage. 60 gigabytes of material, something like that. Okay, the external AFTP, so it's a long list, and we need to keep in contact with the authors that this really works, and it's all bundled. So we don't ask users to install the latest version of a solver or something like that. Okay, emerging technologies, this is very speculative here. I wrote this down almost 2 years ago, and nothing has changed in the meantime. VS Codium and Node.js and so on. So by bundling VS Codium, I get full Node.js and full Chromium also, and I could use this bundled browser, then I have just one browser that I can rely on, and I made an experiment. The link is later there in the slides. 2 years ago, I made an experiment with that. Afterwards, I didn't continue this so far. And maybe Scala.js, which has also improved, but it's not so great. Maybe at some point we could use the Scala source language to target Node.js and Chromium, but I'm not sure yet. F# is a whole code target with APIs for Windows. This is there, but not integrated yet. I need to remind the authors of that they should do something about that. F# is very close to the normal functional languages we have already, then we could somehow connect to Windows. Anyway, so in general, so this is about system integration to make software technology work for us. And what needs to be very, very critical, very, very realistic there to say most technologies are bad. They make a lot of advertisement and so on, so most is bad. And you need substantial efforts for the initial development to make decent technologies actually work and to maintain, to keep technologies working, like Scala 2.7 to Scala 3. This has required 8 weeks to get there. And now we are on this totally different Scala language, or let's say prover updates and so on. One continuously needs to invest there. And after some time you get an idea, is it worth maintaining that, or do we better throw this away? Okay, AFP digital journal with a formal ISSN, and they're inclined to be circular reports. They founded this in 2004. Here you have a little bit of an overview. The number of authors, how does this, for me, is this the most interesting. So over the years, what are the size of the source size of the entries? So in 2014, I was sort of a little bit worried about the overall situation. How will this continue? And we're now here, and we managed again, and we have the technology to scale up a factor of 10. We were speculating a factor of 1,000. I would say for 10, we are there.
What's the last?
This one, sometimes people have an incredibly large project that is submit after a couple of years working on that. The last one you see is Autochorus 2, I think. Okay. Normally when I hover there, I should get the name, but it's now so tiny that I need to change this diagram. So some guy did this diagram when we were here in 2012 or so, that it was, you could hover there to get a number and a name for the spike. And this is Autochorus, which is huge. It takes half an hour to process. This is the C verification environment. Came from Sydney and is now being used in Munich and on the West Coast for C verification. So, an AFP entry, so 8 editors, humans inspecting the submissions. There's a submission page, a web page where you upload your thing. 500 authors, these are often co-authors. Some 2 students did the work and many other people were named. 840 entries. It's like an article in a MISA, or it's a library, or it's like a project in programming. Session is a technical term in Isabelle. An entry can have more than 1 session. Usually it has exactly 1 session. Session is sort of the project structure of Isabelle. 8,000 theories, 270,000 top-level theorems. That is a very, very rough number. 260 megabytes of source text. I think somebody asked about the size.
So you don't bundle it?
Pardon?
You don't bundle it in the Isabelle distribution?
No, it's changing over time. It's changing in a monotonic way. And I would like to have in a normal Isabelle this kind of panel or this kind of GUI element or a tool to say, give me the current version of AFP, and you save to get the latest version. This is very monotonic. So give me now, later you update that maybe. I would like to have this integrated. It's not integrated. It's very unfriendly. So when somebody asks on a conference, can you show me AFP on my laptop, then it takes half a minute to get Isabelle, and then it takes 5 minutes or 10 minutes to have AFP connected to Isabelle. Build time is very, very rough. So on a high-end Apple machine here, it's about 45 CPU hours. This is very fast. It used to be 2 times more on other hardware. Maybe 4 hours elapsed time. I couldn't test this yesterday. This is very rough, just to give you an idea. Yeah, so how can we cope with that and programming and scaling? So we need to fit the technology together in the proper way, and we need to really take this seriously, and Isabelle Scala is this quite successful approach to do it. 16 years ago when I started this, so we have Scala 3 and Java 21, so stable versions. There's this external IntelliJ Scala ID, which is bad for Scala 3, but it somehow still works. Scala is higher order functional object-oriented programming. I'm using this mostly as a functional language and a little bit of object-oriented programming. I'm using this like ML, like Isabelle ML. It has its own style. And because I'm on the JVM, I can use system tools like TCP, HTTP. So in ML, this would be very difficult. On the JVM, it's easy. Then I make wrappers for this kind of things. And then Fabian built this HTTP server, and I was quite surprised. So you just put Caddy in front, and Caddy does all the real-world connectivity to the internet. And we have our very modest Java-based HTTP server exposed to the world in a very professional way thanks to Caddy. I was quite surprised that this works so well. Databases, so everybody on the Java platform is using databases, so this really works for SQLite and PostgreSQL. And then we have these small things that we need, like SHA-1, SHA-2, UUID, Z standard, this is a C library. And in Isabelle ML, you may invoke this protocol, so the IDE is connected via protocol to the Scala process. You can do this also in batch mode. That ML asks, please compress this block as XLET. It goes over to Scala, and then you get it back, and it works. You don't have to worry about fragile, fringe libraries for ML or C that does do this for us. Isabelle Scala has 300 files and 2.6 megabytes of source. And yesterday I counted, this is a bit more actually than Isabelle Pure. Isabelle Pure is the logical environment, so we have 280 ML files and 2.5 megabytes of ML source. And the language is, the inflation factor is at 1.10 or something like that. So Scala programming is like ML programming. So we have now a slightly larger system management platform for Isabelle than the core logic implementation. And this was surprising for me, that we have now, so Pure is huge. There's so many things in there. And Isabelle Scala has also so many things now. That's great. It works fine. It's really to the point. We don't just waste space there in program text and so on. So it's, okay. This is a side remark. If anybody's interested in this viscodium thing and so on, you can look the links yourself. There's a paper to demonstrate this alternative. So this is a JavaScript-based system integration. We're not using this seriously yet. Scaling for builds. So you maintain AFP, and then you need to check, is this really working? How does a change in Hall impact AFP applications? And we have this Edmund Stoiber constant in Munich. Edmund Stoiber wanted to have 10 minutes from Hauptbahnhof to airport of Munich. Train connection takes 45 minutes. 10 minutes feels instantaneous.
This definition of instantaneous.
Pardon?
This definition of instantaneous is not instantaneous enough.
Instantaneous is 20 milliseconds.
so for a huge key. So it feels instantaneous. What happens if I change this notation in H or L? How does it impact everything else? This is the definition of instantaneous, the Edmund Stoiber constant. And Fabian managed to get this to 9 minutes. Before he started the project, it was 25 minutes on the fastest machine or something like that. For waiting and having a coffee in the meantime and so on, there's this Paris commuter constant. So some locals of Paris, they told me, this is, if you spending 45 minutes on the local train, it's fine. Beyond that, you will move your apartment or your office closer together. And this is now the time for, it's 40 minutes. Fabian managed to get 40 minutes. I looked this up in the paper, 35 minutes, 40 minutes. AFP, yeah, all of AFP, only the very slow sessions are excluded. So we are below the Paris commuter constant. And it was these 5 hours or 8 hours, depending on the hardware. It meant that you couldn't maintain this anymore. You don't wait 8 hours to find out that the notation is not a good idea, something like that. And this paper will soon be online here at LibPix. This is the ITP paper that our names are on there, and Fabian did all the great work for the scheduling and the integration, and I provided the basic technology, and there's a little bit of work out there. It's really great. Now we have a factor of 10 scaling. Just some sketches, how does this work, so the paper is more specific about that we make minimal assumptions about what we expect. So we do expect SSH, and we can expect that. So SSH clients, the protocol is dead. So there's one implementation, OpenSSH, and this works on all platforms, and you can rely on that. And then you have one Postgres server that you run yourself. It's from a normal Linux system. Okay, I don't go into these details. So this is about the cluster build. Fabian had in his talk, there was this build manager front, and there's a website to show the queues that are on cluster and so on. So the conclusion, this is about future work. I want to have more PIDE support for AFP and for cluster builds. While you're sitting there trying, I want to see the status of the build attempts. Lessons learned from Isabelle Scala in the past 15 years. Scala is a very good programming language for doing system integration. I'm very glad that we got rid of our Perl scripts, and we could get very, very ambitious without having problems. Bundling all the dependencies is very important for dependability, and it imitates ideas from NixOS and Docker without all this huge thing I get. So you only get a very modest approach to achieve that. Outsourcing the responsibility for important components is very risky, like IntelliJ idea for Scala, so I will never do this again. Many people have problems thinking in terms of multiple language and cultures like Hall or ML or Scala, even though there's an overall overlap how you work. But many people think this is frightening. So some people say, I'm working in Hall all the time, I'm sometimes working here, and hardly anybody ventured in there, so let's see how this changes. Or maybe not, so we need to be very educated. Anyway, so we are ready for factor 10 scaling, I would say.